Let's travel back to the 1980s, a time of big hair, iconic music, and groundbreaking technological advancements that were just beginning to shape the world we know today. A decade of innovation where personal computers were becoming more accessible and the seeds of the digital revolution were being sown. While most enjoyed cassette tapes, Walkmans, and the rise of MTV, engineer Chuck Hull, a name that would become synonymous with innovation, was about to change manufacturing forever, embarking on a journey that would revolutionize how we create and build. Working with UV light to coat furniture, a process he knew intimately, Hull wondered. What if you could harness the power of this light, not just to coat surfaces, but to build entire objects, layer by delicate layer, transforming digital designs into tangible realities? This revolutionary idea, born from curiosity and ingenuity, became stereolithography, the bedrock of modern 3D printing. Imagine a vat of liquid plastic, a special resin that possesses the remarkable ability to harden and solidify when exposed to a precisely controlled beam of laser light. A platform gently lowers into this liquid bath, and then, with pinpoint accuracy, a laser draws a shape on the surface, causing a solid layer to form. A testament to the power of light and precision. Repeat this process, layer upon layer, and you build an object from the ground up, a physical manifestation of a digital design brought to life through the magic of additive manufacturing. Unlike traditional subtractive manufacturing, where material is carved away to create a desired shape, this was additive. Material was only added where needed, minimizing waste and maximizing efficiency, a concept that challenged conventional manufacturing paradigms. In 1983, Hull, driven by his vision, printed a small black eyewash cup, the first 3D printed object, a humble yet monumental achievement. It proved his concept worked, validating years of research and development, and marked the birth of 3D printing as we know it. Hull, recognizing the transformative potential of his invention, patented stereolithography in 1984, securing his place in history, and co-founded 3D Systems in 1986, a pioneering company that would spearhead the development and commercialization of 3D printing technology. Launching the first commercial 3D printer, the SLA-1, in 1987, a machine that would pave the way for the widespread adoption of additive manufacturing. Early machines were expensive and complex, requiring specialized knowledge and significant investment, used only by large corporations and labs, pushing the boundaries of innovation in controlled environments. For most people, 3D printing was still science fiction, a concept relegated to the realm of futuristic fantasies and technological speculation. But the foundation was set, the groundwork laid for a new era of making, a paradigm shift in how we design, prototype, and manufacture products. The door to a whole new world of manufacturing had been opened, inviting exploration, experimentation, and the realization of previously unimaginable possibilities. The journey of 3D printing had just begun, a journey that would traverse decades of innovation, refinement, and widespread adoption. And it would soon change everything, transforming industries, empowering individuals, and shaping the future of manufacturing in profound and lasting ways. In the late 1980s and early 1990s, a quiet revolution was brewing within the walls of large corporations and specialized research labs. 3D printing, still in its infancy, was a secret weapon for big companies, offering a competitive edge that few could match. It was a time of experimentation and discovery. It revolutionized rapid prototyping, a game changer for product development cycles. Engineers could print prototypes overnight, pushing the boundaries of what was possible in product creation. Instead of waiting weeks or even months for traditional molds, prototypes could be realized in a matter of hours. This saved significant time and money, dramatically accelerating the pace of innovation and allowing companies to bring products to market faster than ever before. But Chuck Hull's stereolithography, SLA, wasn't the only game in town. The field was rapidly diversifying, with new approaches emerging. In 1988, Carl Deckard invented selective laser sintering, SLS, adding another powerful tool to the 3D printing arsenal. SLS used lasers to fuse powder into solid layers, a process known as powder bed fusion. This opened the door to printing with a wider range of materials, including metals and ceramics, expanding the possibilities for industrial applications. Around the same time, Scott Crump developed fused deposition modeling, FDM, a technology that would eventually revolutionize the consumer market. The inspiration for FDM came from an unlikely source, a humble hot glue gun. FDM worked by extruding melted plastic layer by layer to build three-dimensional objects. FDM was simpler and cheaper than other 3D printing methods, making it a more accessible option. This simplicity and affordability laid the groundwork for the development of desktop 3D printers, bringing the technology closer to home. For years, these technologies remained largely confined to industrial settings. The machines were huge and expensive, the materials proprietary and specialized, and the underlying patents tightly held, limiting broader adoption. 3D printers were seen as specialized tools, requiring trained operators and significant investment, putting them out of reach for most hobbyists and small businesses. But as key patents neared their expiration dates, the landscape began to shift. Change was on the horizon, promising a future where 3D printing would be more accessible and widespread. The stage was set for 3D printing to undergo a dramatic transformation, to break free from the confines of the factory floor and enter the realm of everyday life, empowering individuals and small businesses alike. A new chapter was about to begin, one that would redefine manufacturing and creativity. The world of personal making and DIY innovation was on the verge of a revolution, fueled by the democratization of 3D printing technology. Soon, anyone with an idea and a 3D printer could become a creator, bringing their visions to life with unprecedented ease. The barriers to entry were about to fall, opening up a world of possibilities for individuals and small businesses. 3D printing was poised to go mainstream, transforming the way we design, manufacture, and consume products. The future of manufacturing and personal creation was closer than ever, promising a world where innovation knows no bounds. The real 3D printing revolution began in the mid-2000s. As FDM patents expired, Dr. Adrian Boyer launched the RepRap project, an open-source printer that could replicate itself. This sparked a global community of makers, sharing designs and improvements online. Suddenly, anyone could build a 3D printer for a fraction of the old cost. Desktop 3D printing was born, moving from factories to homes and classrooms. Companies like MakerBot and Prusa made user-friendly printers, refining both hardware and software. Slicer programs became intuitive. Just load a model and click print. Printers grew faster and more precise, with features like heated beds and auto-leveling now standard. Continuous improvement made 3D printing accessible, reliable, and powerful. What started as a niche hobby became a mainstream creative tool. The maker movement was in full swing. 3D printing was now for everyone. Early desktop 3D printing meant choosing between ABS or PLA plastic, but makers wanted more: flexibility, strength, and new aesthetics. This demand led to a boom in innovative filaments. Now you can print with PTG for strength, TPU for flexibility, or even wood-filled plastics and metal-filled plastics for unique looks and textures. Filaments with carbon fiber or fiberglass offer lightweight strength for engineering projects. Conductive filaments let you print simple circuits. The explosion of materials transformed 3D printing into a versatile manufacturing platform. From functional gears to artistic sculptures, the possibilities are endless. 3D printing is no longer just for models, it's for real-world solutions. The only limit is your imagination. The material revolution is here. While hobbyists explored 3D printing, industries quietly transformed. Additive manufacturing now creates final parts, not just prototypes. Factories print custom tools and jigs on demand, boosting efficiency and ergonomics. Companies like Volkswagen and BMW print thousands of assembly aids each year, speeding up production and improving worker safety. 3D printing enables complex designs, like internal channels or lattice structures, impossible with traditional methods. Generative design, powered by AI, creates lighter, stronger parts. GE's 3D printed jet engine nozzles are lighter, more durable, and made as a single piece instead of many. Additive manufacturing isn't just a replacement, it's a new way to build. It unlocks products and designs that were once unimaginable. The future of manufacturing is being printed today. Efficiency, creativity, and performance are reaching new heights. 3D printing is reshaping industry. The revolution is underway. 3D printing's impact on medicine is nothing short of miraculous. Custom surgical guides made from patient scans improve accuracy and recovery in complex surgeries. 3D printed prosthetics are now affordable and customizable, thanks to organizations like Enable. Implants tailored to a patient's anatomy like titanium skull or jaw replacements fit perfectly and encourage bone growth. Bioprinting is the next frontier. Researchers are printing tissues like liver, skin, and cartilage. While full organs are still in the future, the potential is breathtaking. 3D printing personalizes medicine, making treatments more effective and accessible. It's transforming lives and pushing the boundaries of what's possible. The future of healthcare is being printed one layer at a time. Innovation in medicine has never been faster. The possibilities are limitless. In aerospace, every gram matters. 3D printing lets engineers create lightweight, strong parts with complex geometries, impossible by traditional means. Companies like Relativity Space are 3D printing entire rockets, slashing production time and simplifying supply chains. NASA tests 3D printers on the International Space Station, proving in-space manufacturing for future missions. If a tool breaks on Mars, astronauts can print a replacement on demand. Rapid prototyping accelerates innovation. Engineers can design, print, and test new parts in weeks, not years. 3D printing is central to the next generation of space exploration. It's making spaceflight cheaper, faster, and more ambitious. The boundaries of possibility are expanding. From jet engines to Mars habitats, additive manufacturing is key. Aerospace is reaching new heights, layer by layer. The stars are within reach. For hobbyists, a 3D printer isn't just a tool, it's a portal. It's a way to bring your imagination to life right on your desktop. A 3D printer is a gateway to creativity, unlocking a world of possibilities for crafting, designing, and problem solving. Millions of free models online, readily available for download and printing. This means you can print almost anything your heart desires, from practical tools to whimsical creations. Start with simple projects like phone stands to game pieces, enhancing your board game nights with custom-designed components. And you can do all of this without needing extensive design experience. But the real magic truly begins when you start designing your own parts. You can fix a broken knob, bringing new life to old furniture and appliances. Or customize a gadget, tailoring it perfectly to your needs and preferences. Or even invent something entirely new, pushing the boundaries of what's possible. 3D printing empowers you to repair items around your home, create unique objects, and personalize your world, making it a reflection of your own creativity. It complements other hobbies, seamlessly integrating with your existing passions. You can print enclosures for electronics projects, giving them a professional and polished look. Create custom planters for gardening, adding a personal touch to your green space. Or even fabricate parts for RC vehicles, enhancing their performance and appearance. Affordable, reliable printers are now readily available, and a supportive community is there to help you along the way, offering guidance and inspiration. This makes getting started easier than ever before. 3D printing turns anyone into a maker and problem solver, empowering you to tackle challenges with creativity and ingenuity. The only limit is your imagination, so let your creativity run wild. It's never been easier to join the maker movement, a vibrant community of innovators and creators. Creativity and innovation are now at your fingertips, ready to be unleashed. The future of making is in your hands, so embrace the power of personal fabrication. Start printing and see what you can create. The possibilities are endless. The journey is just beginning, and it's filled with exciting opportunities for discovery and innovation. The evolution of 3D printing is accelerating. Soon, printers will handle multiple materials and colors in a single job, with AI ensuring perfect results. 4D printing, objects that change shape over time, is emerging. Large-scale printers are building houses, while desktop metal printing is on the horizon for hobbyists. The line between amateur and professional is blurring. 3D printing democratizes manufacturing, putting invention in everyone's hands. From Chuck Hull's first cup to rockets and living tissues, the journey has been incredible. The next chapter belongs to a new generation of makers and dreamers. There's never been a more exciting time to press print. The future is yours to create.